Hi guys, this is Miles Vandergriff, and I wanted to make a screencast going over Assignment 5, which is your Next Generation Science Standard Lesson Design Project. This is the last and the culminating project of this course, and I wanted to go through the different steps and to make sure that you understand the expectations of this project. So if you take a look at step 1, it says to choose one or more next generation science standard performance expectations, which is equal to the actual standard. It is the science competencies or the outcomes that students should be able to do by the end of instruction. And so we've got a lot of links down here. So let's go ahead and take a look at the first link. Is from the County Office of Ed. So if you're doing middle school, this is physical science. You can see all of them in here. Or if you're here for the life science, you can see all of the performance expectations there. So you can click on there and find them there. Or you can go to ngss.org and you can put in the grade and discipline core ideas and you can search for them that way. Or this one is from the Wonder of Science, and you can see these are all elementary school. There's 72 performance expectations from K to 5th grade. And then if you look at the next ones, these are the middle school ones, and there's 55. And again, each of these on the Wonder of Science, you can go under the resources. Paul Anderson has color-coded them from the Science and Engineering Practice, and then the orange is the DCI, and then the green would be the cross-cutting concept. And then for high school, I believe there's 67 performance expectations right there. So that is how you can get to your actual performance expectation or standard. So once you've chosen one, if you choose more than one, you can bundle those together. It's a little more challenging, but you really need to make sure you understand what the standard, the performance expectation is requiring the students to do. Is it to analyze and interpret data? Is it to design an investigation and conduct that investigation? Is it to develop a model and use it to come up with a scientific explanation? So you need to understand what is required from that performance expectation. And then the next step is you want to choose a phenomenon that supports that standard that you've chosen. One that's going to engage the students, one that they are going to want to know and figure out and solve what's going on. There's quite a few links here, and I wanted to show you those. So we've got Project Phenomena at the County Office of Ed, so some really cool things here. Star, pearlfish living in a sea cucumber's bum, Mercury transit across the sun, and again you can search. There's wonderful resources here, and we've got this one, TJ McKenna, and he's got this phenomena for NGSS here. Then you've got the science teaching for Georgia and Phenomena Bank. Some amazing resources there. And then you have the Wonder of Science again, and it is categorized according to grade. So if you were to go into, let's say, middle school, you could do middle school life or earth or physical and click on there and then click on any of these, and then there'll be a list of phenomena there. After you've chosen a phenomena that you're going to open up with, what you want to do is make sure you've read Chapter 8 and Roger Bybee's book, Translating the Next Generation Science Standards into the Classroom, as a guide or resource. And then you want to go through here and look at these links here. So first, Jonathan Osborne interview. It's excellent. It's only 2 minutes, referring to really what a next generation science standard assessment looks like. That's with SNAP, the Standard Assessment Project. Let's see what we've got here. And then from there, you can take a look at all these different performance expectation resources. I want to encourage you, you can look at all of these here, but please, please, please make sure that you are designing and creating your own assessment. You can use those as examples of what you should be doing. Let me just give you an example here from the Stanford uh, assessment project. This one's for deer population. Ties right in to the resources and how it's um, affecting the living and non-living things and ecosystem. And so it's talking about the numbers of deer in Colorado. That's the phenomena. And then you're supposed to describe what you think's happening, and then what's possibly causing the increase or decrease in the population of the deer. And then from there, they've got this chart that lets you list the patterns that you see and what these patterns are telling you about the change in the population of the deer. But you're going to use this by looking at the information here, this graph, the deer and the elk, this graph here, or table with the sagebrush and the cheatgrass, and then also this one with the fawn deaths right here, and I think rainfall. So there's 4 pieces of information that students will collect and look for patterns, and then how those patterns are causing the decrease or increase in the population of deer. And then last, I think there ends with a claim, evidence, and reasoning little paragraph at the end. So an excellent example. There's another one here with waves, talking about ultrasound and locating an ancient, ancient shipwreck and using sonar. And then the students are supposed to be analyzing these different wavelengths and changing them accordingly, checking for their understanding of the anatomy of waves and the energy and amplitude. So, let's go back to, there we go, right here. So that's once you've designed your assessment, you want to come up with a rubric for your assessment. And again, you want to actually take your assessment. And then what would you expect an exemplary student's response to look like? So you want to do that on top of any type of grid rubric that you come up with. I have some resources and links here. And then the 5th step is you want to outline a logical instructional sequence of lessons that would give students the experience and knowledge and skills to demonstrate mastery on the assessment that you've created. So let's take a look here. Here's the instructional sequence. This is the template, so just make a copy of it. This is what it looks like when it's filled out. This was, what is this? 3 weeks of instruction, including the actual assessment here. This is for my waves unit that myself and a student teacher put together a few years back. Take a look at that. And let's go back here. So that's step 5. Step 6 is you want to create a UBD 5E NGSS lesson plan for one of these lessons. Just one of the lessons. So just one of these lessons in your instructional sequence. Not all of them, but you want to flesh out just one of them in great detail using this template. So let's see where that template is. Do I have that? Here we go. So again, I've got the link. Go ahead and just make a copy of that template and then fill that in. Again, this is all with Grant Wiggins, UBD, Understanding by Design, starting with the end in mind, which would be your performance expectation or the goal for that lesson. And then you're going to be working backwards. Using the 5 E's here from Roger Bybee, going backwards, the engagement, explore, explain, extension, evaluation. Try to hit all of those if you can within that one lesson that you're going to be doing that. And again, what modifications, differentiation would you do for your ELL learners and your SPED students? And then last here is I really want to know which performance expectation that this lesson is giving the skills and knowledge for students to get ready for them to master that. The core idea, the science practices, cross-cutting concepts, and exactly what that looks like in the lesson. And I think if you click here, there is an example. There's a couple examples. Let's take a look at this one. So again, this one here is going through the details, and this one's on waves. And then make sure that you are ready to walk us through maybe the first 5-10 minutes of your lesson how you created your assessment and what your rubric looks like. Show us all of that, and then probably give you about 20 minutes to actually teach if you'd like to teach a portion of that lesson. So hopefully you found this screencast helpful, kind of walking you through the details of your lesson, your NGSS lesson design project. I'm really excited to see what you guys come up with. Again, I know this is not easy. I know it's a lot of work, but again, good teaching is always a lot of hard work, but it's extremely rewarding when you see how much your students have grown, how much they've learned, and the mastery of the next generation science standards. So hopefully this has been helpful.